Greetings and namaskar to each one who came here to watch this video. So this video and the upcoming videos will be the series of the CSIR-NET Physical Science. And today we are going to start electronics. And in it we are going to start operational amplifier, that is OPAM, which is one of the most important topic, and you will definitely see few questions from this topic in your competitive exam. And here we will try to solve as many as questions possible. So let's start. So here the first question is, find output voltage of following ideal OPAM circuit. So in this question we have to find this V0, which is output voltage. So let's first mark the points for our ease. Let's suppose this point is A and this point is B. The easiest way to solve any question of these types is by using Kirchhoff's law. What it says? That the incoming current is equals to the outgoing current. So for that, let's suppose the current entering this side is I1 and going to this side is I2. Similarly, the current entering from this side is, let's suppose, I3, and which is passing from here, let's say it's I4. Now as you can see, the voltage is given here, but what about voltages at these points? So for now, let us mark it as Vx. This unknown voltage is Vx. And by the concept of virtual ground, this is also Vx. Now as you can see, this OPAM is differential amplifier. Why? Because these two resistance, that is RF and R2, are equal. Therefore it is a differential amplifier. And now how to solve it? So there are two ways to solve these types of questions. One is by using the formula and the other is without using the formula. So by chance you forget the formula, so no need to remember the formula. Other than that, use the easy concept to solve these questions. Follow the concept of Kirchhoff's law, that is, incoming current is equals to the outgoing current, and simplify the problem. So let's start with the first method, that is without using formula, by just putting the incoming current equals to the outgoing current. So let's first take at point B. So at point B, the incoming current, that is I1, is equals to the outgoing current, that is I2. So let's put them equal, that is I1 is equals to I2. Now from the Ohm's law, that is V equals to IR. So here I is equals to V by R. So we are going to take the difference in potential divided by resistance, that is R. So for I1, we are going to subtract this 1 volt minus Vx, and similarly for I2 we are going to subtract Vx minus 0. Why 0? Because it is grounded. So we will take this voltage as 0. So 1 minus Vx upon the resistance here is 3 ohm. So we will write 3 is equals to Vx minus 0 for I2 upon, here the resistance is 9. So we'll write 9. Now just simplifying it, 1 minus Vx is equals to Vx divided by 3. 3 ones 3, 3 times 9. So Vx by 3, and solving further we get 3 minus 3Vx is equals to Vx. So we get Vx is equals to 3 by 4. From here we get the value of Vx, that is 3 by 4. Similarly, we will solve for point A. Here the incoming current is I3 and the outgoing current is I4. So putting them equal, we will write at point A, I3 is equals to I4. incoming current is equals to outgoing current. So I3 is equals to I4. Again, the same concept, I is equals to V by R. So V is 3 volt here and Vx here. So we will minus 3 volt minus Vx divided by the resistance, that is 3 ohm. And for I4, Vx minus V0 divided by 9 ohm, the resistance over here for I4. So 3 minus Vx divided by 3 ohm. So 3 is equals to Vx minus V0 divided by 9. Now let's solve it. 3 times 9. So simplifying it, we can write 9 minus 3Vx is equals to Vx minus V0. And let's write it in terms of V0. Let's move V0 to the left hand side and the rest term to the right hand side. That is 4Vx minus 9. And now let's put the value of Vx, that is 3 by 4 over here. And we will get 4 into 3 by 4 minus 9. Putting the value of Vx, that is 3 by 4 here, and solving it, we will get V0, that is output voltage, is equals to minus 6 volt. So this is the simplest way to solve this question without the formula. Now the alternative method. So the direct formula for voltage output of differential op-amp is, let me write alternate method. So the formula of voltage output is V0 is equals to RF divided by R V2 minus V1. So now using this formula you can directly find V0. So the value of RF is this feedback resistance, that is 9 ohm, is the RF, and this R is the resistance, and V2 minus V1, this is V1 and this is V2. So just putting these values in the formula, we will get RF is 9 ohm divided by R, that is 3 ohm. V2 minus V1 means 1 minus 3. And here we get minus 6 volt. That is our output voltage. So this is it. Now moving to the next question. So this is the next question, in which we have to find the load resistance, that is RL, in terms of Vs, R and V0. So again we are going to solve this question with the same concept, that is incoming current is equals to the outgoing current. Here there are no numerical values, no need to worry. Just go with the concept in flow, you will easily get the values. Now let's first mark the points. Let us say it is point A, this is point B, and let us say the voltage at point A is Vx, and similarly with the concept of virtual ground, the voltage at point B is also Vx. Now let's mark the current. So let us say that this incoming current is I1. Here this outgoing current is I2. Similarly at this side, let this be I3 entering from this side, and this outgoing current will be, let us say, I4. So that's it. Now let's solve it. Let's first solve it for point A. From here we will get the value of Vx, and using that value we will put while solving at point B, and we will get the load resistance. Let's see. So at point A, I1 is equals to I2. Now again I is equals to V by R. So here V is Vs minus Vx. So Vs minus Vx divided by resistance. Here resistance is R1 is equals to outgoing current. So Vx at this end and following by V0 at the other end. So Vx minus V0 divided by R1. So cancelling them, we will get Vs minus Vx is equals to Vx minus V0. Further solving them, Vs taking V0 to the left hand side plus V0 is equals to 2 of Vx. Now writing it in terms of Vx. So Vx is equals to Vs plus V0 divided by 2. So here we get the value of Vx, that is Vs plus V0 divided by 2. Now let's solve for point B. So at point B, I3 is equals to I4. At point B, I3 is equals to I4. So for I3, voltage over here is 0 because it is grounded. So 0 minus Vx. Voltage at point B is Vx. So 0 minus Vx divided by the resistance here is R. So R is equals to, for I4, Vx minus V0 divided by RL. Now let's solve it further, taking RL to the left hand side. So RL divided by R is equals to, taking this minus Vx to the right hand side. So we will get Vx minus V0 divided by minus Vx. And now let's take this minus outside, dividing each term by Vx. So minus Vx divided by Vx is 1 minus V0 divided by Vx. Now multiplying this minus sign throughout. So we will get this as positive term, minus minus plus, and this one as negative. So V0 divided by Vx minus 1. So here we finally get Vx, and now it's time to use this value of Vx that we had taken from point A. So using this value of Vx over here. So now using this Vx over here, we will get RL upon R is equals to V0 divided by Vs plus V0 divided by 2 minus 1. And now solving it further, we will get 2V0 minus Vs plus V0 whole divided by Vs plus V0. Solving further, we get V0 minus Vs divided by Vs plus V0. Now taking this R to the right hand side, we can finally write RL is equals to V0 minus Vs divided by Vs plus V0 multiplied by R. So here we get the value of RL, that is load resistance. So here we get the value of load resistance, as you can see in the question, in terms of Vs, R and V0. Vs, R and V0. So as you can see, again by using the simplest concept, that is putting incoming current equals to outgoing current, you will be able to solve the questions very easily. One more thing to remember is the subtraction part you are doing over here, that is Vs minus Vx or Vx minus V0. You need to remember the direction. If current is flowing from Vs to Vx, then you will write Vs minus Vx. If current is moving from Vx to Vs, then you have to write Vx minus Vs. So it depends on the direction of current. As you can see here at point B, for I, we have taken 0 minus Vx because the current is flowing from 0 volt to Vx. So 0 minus Vx. And for I4, the current is flowing from Vx to V0. We have to write Vx first, then V0. Now moving to the next question. So in this question, we have to find the value of I0, that is this current. So again, by using the same concept, that is incoming current is equals to the outgoing current. Now let's first mark the points. Let this point be A and this point be B. Now what about the voltage? Here we have the voltage supply of 2 volt. So again, by the concept of virtual ground, this point is also has 2 volt. Now let's mark the current. Let the incoming current by this side is I1 and the outgoing current be I2. And the current flowing from this side be I3. And we already have the I0 and the direction is also given. So again we will solve for point A first, and from here we will get the value of V0. And by using that, at point B, we can get the value of I0. So let's solve it. So at point A, I1 is equals to I2. And now V by R, so 6 volt minus 2 volt. That is 6 minus 2 divided by the resistance here is 5 kilo ohm. You have to just be aware of the units you are using. Here it is given in kilo ohms. So 5 is equals to I2, that is 2 volt minus V0. So 2 minus V0 divided by resistance here is 25 kilo ohm. So 25. Now let's solve it. 5 times 25. So simplifying this, we will get 20 is equals to 2 minus V0. So we will get the value of V0 as minus 18 volt. Now let's solve for point B. So at point B, you can see the incoming current is I2. So we will write I2 is equals to, the outgoing current is I0 plus I3. So I2 is equals to I0 plus I3. Alright, I2 is equals to I0 plus I3. Now let's write I2 is 2 volt minus V0. So 2 minus V0 divided by the resistance here is 25 kilo ohm. So 25 is equals to, so we have to write I0 as it is because we have to find the value of I0 here. So I0 plus I3. For I3 we have to write V0 minus 10. So we will write it as V0 minus 10 divided by 10 kilo ohm. So 10. Here we can directly use the value of V0, that is minus 18 volt over here. So it will become 2 minus 18, alright, divided by 25 is equals to I0 plus minus 18 plus 10 divided by 10. So you can write 2 plus 18, 20 divided by 25 is equals to I0 minus 8 by 10. Solving further, taking this numerical value to the opposite side, we will get I0 is equals to 20 by 25 plus 8 by 10. So, taking LCM, we will get 40 plus 40 divided by 50. And this is equals to 8 by 5. So, this is the value of I0, that is milliampere. So, here we get the value of I0, that is 8 by 5. So, as you can see, you have to do nothing else except just putting the incoming current equals to the outgoing current. That's it. Now let's move to the next question. So here we go for the next question. In this we have to find output voltage V0, that is this V0. And here you can see we have 3 resistance, and this time this is grounded, means this is going to be 0. And again using the same concept of incoming current is equals to outgoing current. So let's mark the points first. So let us say this point as A and this point as B. If we talk about voltage, so it is already given that this is V1, V2 and V3. So let's say this is Vx, and similarly this is also Vx. Now let's mark the direction of the current. Let this be I1, the next one will be I2 and this I3. And let us say that this is I4 and this outgoing current is I5. So here we go. Firstly, let's calculate at point B. From here we will get the value of Vx, and while solving for A and putting the value of Vx, we will be able to find the value of V0. So let's do it. At point B, the incoming current. So here we can see 3 incoming currents are there, I1, I2 and I3. But there is no outgoing current. So we will put it equals to 0. So let's write it. I1 plus I2 plus I3 is equals to 0. Now the voltage subtraction, that is V1 minus Vx, V2 minus Vx, V3 minus Vx, and the resistance is common, that is R. So let's write it. For I1, V1 minus Vx, V1 minus Vx divided by R, plus V2 minus Vx divided by R, plus V3 minus Vx divided by R is equals to 0. And now taking R common, and if we take it to the right hand side, it will become 0. And then you can just add V1 plus V2 plus V3, and 3 minus V's are there. minus Vx minus Vx minus Vx. So you can write minus 3Vx. So here we go. V1 plus V2 plus V3 minus 3Vx is equals to 0. And from here we can take out the value of Vx. Vx is equals to V1 plus V2 plus V3 divided by taking this 3 in the denominator. So we will get 3 here. So now let's move and solve for point A. So at point A, I4 is equals to I5. And here as it is grounded, so 0 minus Vx is equals to Vx minus V0. 0 minus Vx divided by its resistance is R. So here we write R and Vx minus V0. Denominator again R. Now this will cancel out and we can see that this is minus Vx is equals to Vx minus V0. From here we will get V0 is equals to twice of Vx. And now simply using this value of Vx over here, we will get V0 is equals to 2 by 3 and the rest as it is, that is V1 plus V2 plus V3. So here we get the output voltage, that is V0 is equals to 2 by 3 V1 plus V2 plus V3. So this is it. Hope you found this video productive. Thanks for giving your time here. Take care.